ihasmath, and you're going to learn how to identify the equation of a line from its graph. I think you already know how to do this, because you know how to draw a line graph from an equation, and you just need to practice to use your understanding in a slightly different way. So let's get right into it. I'm going to show you a few line graphs, and I challenge you to pause the video and try to write down the equations yourself before you continue watching. Hashtag line graph challenge. Pause now and try to write down the equations. Here are the answers. Did you get all of them right? They shouldn't have been too difficult. Just identify y-intercept and gradient and then pop them into the equation y is equal to mx plus c. Of course, I included some special ones. Just think about which coordinate remains unchanged for all the points on these lines. That's your rule and also your equation. Let's step this up a bit. Sometimes the axes are different to what you're used to. For example, the y-intercept might be so high up that the axes don't actually show the pips for each number. Give this one a go. Pause the video and see whether you can still work out the equation. Did you get it right? The method is the same. You find the y-intercept and then draw a triangle to work out the gradient. Use your calculator to check whether you can simplify the gradient. It would be impolite not to do so. Non-standard axes often occur in applications questions when, for example, the horizontal axis represents the number of weeks and the vertical axis the amount of money saved. You would hope that you're able to save more than $1 a week. So it probably makes sense to have different scales on the axes. Give this one a go. Pause the video and see whether you can work out the equation. Did you get this one? I hope so. Again, don't forget to simplify the gradient if possible. If you remember your gradient intercept form and the special cases of horizontal and vertical lines, you shouldn't find this too difficult. Just make sure that you check the axes before you start. Sometimes students make mistakes because they assume that a pip always means 1, and you know what Benny Hill thought about that.